Hello everyone, welcome to day 30th of March Leetcode challenge, and I hope all of you are having a great time. The question that we have in today is search a 2D matrix. So here in this question we are given a target element, we are given a 2D matrix. What we need to do, we need to identify whether the target element is present in this 2D matrix or not. Also it is specified that the rows are sorted in nature as well as the columns are also sorted in nature. So the entire matrix is sorted row wise and column wise. This is a very important point, and since the question itself says that the rows and columns are sorted, what we should do, we should look out for binary search kind of an approach. Why? As soon as you see the word sorting, the one thing that should click your mind is binary search algo. How are we going to apply it over here? Let's quickly have a look at the presentation section. Also, in case you have any doubt or looking for any help from me, please feel free to ping on the Telegram group of Coding Decoded, Discord server of Coding Decoded, or even LinkedIn page of Coding Decoded. I'm looking out for feedback, comments, your thoughts about this channel and how Coding Decoded is helping you out get through the journey of your dream companies. Now let's get back to the question. Leetcode 74, search a 2D matrix. It's a medium level question on Leetcode, and I totally feel the same. Now let's take the same example that was specified in the question. The hint that we already have is to somewhere apply binary search algorithm. How can we do that? Let's walk through the same example that was specified in the question. Let's assume the target element to be 3 itself, and what we will be going to do, we'll start from the bottom left corner of our matrix. And what value do we see here? We see 23 here. 23 is way larger than our target element. That simply signifies that this element, the target element, can't be present in the entire row corresponding to 23, because all these subsequent elements will be higher than 23. The question said the rows are sorted in nature in ascending order. So what we should do, we should simply skip this entire row. So let's skip this entire row. Let's go back to the previous one. What element do we see? We see 10. 10 again happens to be way greater than our target element. As a result of which we can say that our target element will not be present in this entire row. What is the next action item that we have? We should reduce the row count. Row count gets reduced by 1 and we reach the first row. What element do we see? We see here 1. 1 happens to be lower than their target element. That simply means that target element could be present in this entire row, and this is our target row. We have successfully identified our target row. Now the question said the rows are sorted in nature and we have an array. Consider this as a separate array, and we want to look out for this target element in this sorted row. It can be easily done using the binary search technique. You apply binary search on this particular row and you find out whether this target element is present in this array or not. If it is present, you return true, otherwise you return false. So the problem reduces to actually identifying the correct row where you should apply the binary search technique, and this is all. This is not a very complicated question, and it can be highly asked in interviews so as to check the thought process of the candidate. The time complexity of this approach would be equal to order of number of rows that we have, because there could be case where we find out the target row in the last iteration, as a result of which we have to iterate back to the 0th row, and therefore the time complexity would be equal to the number of rows that we have plus we are applying binary search on the entire row, and the number of elements in the entire row would be equal to the number of columns that we have. These signify the number of columns that are present. Therefore, the total time complexity would be equal to order of row plus log of C. This brings me to the end of today's session, and let's quickly walk through the coding section and conclude the final coding part. Here I have extracted the number of rows that I have, the number of columns that I have. X length and Y length signify these. These are the corner cases that I have written, and now I'm going to the bottom left cell, and I turns out to be the last row in my matrix. J turns out to be the first column in my matrix, and I keep on checking till the time my matrix at I comma j index happens to be greater than my target. With each iteration, I simply reduce the value of row count, and once I break out of this loop, what will I get? I'll reach my target row. In case my I happens to be less than 0, that simply means that my target element is not present in my entire matrix. After this is another corner case that we should think of while writing code. And once I have identified my target row, what do? I extract that entire row in a new array, and I apply binary search on that array. I also pass the target element that I am looking for. If my index turns out to be greater than 0, I simply return true, otherwise I return false. This is a helper method that I have created that is basically using binary search technique to search this target element in my entire array. Pretty simple and straightforward, no rocket science here. This brings me to the end of today's session. I hope you enjoyed it. If you did, please don't forget to like, share and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'll see you tomorrow with another fresh question. But till then, goodbye.